This sound changed everything. This engine rewrote American automotive history, and this secret nearly destroyed Chevrolet before it could save them. The 265 Turbo Fire wasn't just revolutionary, it was a beautiful assassin. Praised as the small block savior by engineers who designed it, cursed as the oil-starved killer by mechanics who had to fix it. How did one engine simultaneously rescue Chevrolet from obsolescence while almost murdering its own reputation? How did it dominate racetracks on Sunday while self-destructing in driveways on Monday? The truth is more dramatic than any marketing campaign ever dared admit. By 1954, Chevrolet was bleeding market share and running out of time. While Ford's flathead V8 had been dominating American roads since the 1930s, Chevrolet stubbornly clung to their inline six-cylinder engines like a relic from another era. The automotive world was demanding V8 power, and Chevy was showing up to a gunfight with a pocket knife. The numbers were brutal and getting worse. Ford's new Y-block V8 was making Chevrolet look hopelessly outdated, and customers were defecting in droves. Corporate panic reached fever pitch when market research revealed that over 50% of car buyers now demanded V8 engines as standard equipment. Chevrolet's six-cylinder philosophy wasn't just old-fashioned, it was commercial suicide. The statistics painted an even grimmer picture. In 1950, only 26% of buyers wanted V8 power. By 1952, that number had climbed to 33%. By 1954, it was approaching 50% and rising fast. Chevrolet's general manager Thomas Keating didn't mince words in his desperate memo to GM headquarters. "We've become too six-cylinder-minded." His warning triggered what would become known as GM's billion-dollar gamble, massive factory investments in Flint, Michigan, and a complete rethinking of Chevrolet's engine philosophy. The company that had built its reputation on reliable, economical six-cylinder engines was about to bet everything on unproven V8 technology. Enter Ed Cole, the brilliant engineer who would either save Chevrolet or watch it die trying. His mission was simple and impossible: design a V8 engine that could beat Ford at their own game while being lighter, more efficient, and cheaper to manufacture. The timeline was insane, the pressure was crushing, and failure meant corporate extinction. Cole looked at the challenge and made a decision that would echo through automotive history. Forget everything that came before. This wouldn't be an evolution, it would be a revolution. Ed Cole didn't believe in half measures or incremental improvements. When Chevrolet's engineering team gathered to tackle the V8 challenge, Cole made one thing crystal clear. "We're not tweaking an old design. We start with a clean sheet of paper." And that clean sheet approach would revolutionize everything about how engines were built. The breakthrough came with an audacious decision to abandon traditional engine construction methods entirely. While competitors were building heavy, bulky V8s using conventional wisdom, Cole's team pioneered thin-wall casting technology that would make the 265 lighter and more compact than anything Detroit had ever seen. This wasn't just innovation. It was engineering heresy that violated every rule the industry followed. The manufacturing revolution extended far beyond just making things lighter. Cole's engineers developed new casting techniques using green sand cores that allowed unprecedented precision in cylinder bore placement and wall thickness. They could safely cast walls as thin as 5/32 of an inch, a tolerance that seemed impossible to traditional manufacturers. Every component reflected this radical philosophy. Hollow push rods replaced solid ones, stamped rocker arms eliminated expensive machining, and the intake manifold doubled as a valley pan to save weight and complexity. The result was an engine that weighed 460 pounds compared to competitors that often exceeded 600 pounds. But the real genius wasn't just in what they included, it was in what they eliminated. By questioning every traditional assumption about engine design, Cole's team created something that shouldn't have been possible: a V8 that was both more powerful and more efficient than anything that came before. The final specifications of the 265 Turbo Fire read like a wish list that engineers had dreamed about for decades. At exactly 265.3 cubic inches, it delivered more power per pound than any American production engine in history. The over-square design, with bore larger than stroke, meant this engine was built to breathe and rev, fundamentally different from the long-stroke torque monsters that defined American V8s. The wedge-shaped combustion chambers represented a masterpiece of thermodynamic engineering. Unlike the inefficient bathtub chambers used by competitors, the 265's wedge design created controlled turbulence that mixed fuel and air more thoroughly, resulting in faster, more complete combustion. Spark plug placement was precisely calculated to ensure flame propagation that maximized power while minimizing knock. Hydraulic lifters eliminated valve adjustments that plagued other engines, while the interchangeable cylinder heads simplified both manufacturing and service. The high 8.0-to-1 compression ratio was aggressive for the era, but the superior combustion chamber design made it work reliably on pump gasoline. Perhaps most impressive was the structural rigidity achieved through the compact 21.75-inch block length. This wasn't just about fitting under low hood lines. The short, stiff design eliminated the torsional flex that caused vibration and wear in longer engines. Every dimension had been optimized for both performance and longevity, creating an engine that seemed too good to be true. But the 265 Turbo Fire harbored dark secrets that would nearly destroy Chevrolet's reputation before it could be saved. For all its brilliant engineering, the engine launched with 3 fatal flaws that turned engineering dreams into mechanical nightmares. Flaw number 1 was the oil starvation crisis. In their rush to market, Chevrolet launched the 265 with only an optional bypass oil filter that cleaned just 10% of the engine's oil. The other 90% circulated freely with metal particles, carbon deposits, and abrasive contaminants that acted like liquid sandpaper on precision machined surfaces. Legendary engine builder Smokey Yunick raged, "Chevy gave us a great motor, but forgot to keep it alive." Flaw number 2 was even more insidious. The overheating assassin lurking within the tight manufacturing tolerances. The same precision clearances that made the engine efficient became deadly under thermal stress. When pistons expanded beyond safe limits in hot climates or under hard use, they scoured cylinder walls like grinding wheels. Southern dealerships reported epidemic piston seizures that earned the 265 the nickname the Scuffer. Flaw number 3 revealed the consequences of corporate panic. Missing positive crankcase ventilation, primitive oil breather systems, and inadequate camshaft lubrication proved that the 265 was essentially a prototype rushed into production. Chevrolet was so desperate to beat Ford that they shipped an engineer's dream that became a mechanic's nightmare. The contradiction was staggering and heartbreaking. On NASCAR ovals, the 265 Turbo Fire was rewriting the record books and humiliating Ford's supposedly superior Y-block. Herb Thomas piloted his Smokey Yunick-prepared Chevrolet to 12 victories in 1955, including the prestigious Southern 500, proving that when the little mouse motor stayed together, it had the heart of a lion. Racing statistics told an incredible story of dominance. Tim Flock captured 18 pole positions, showcasing raw speed that left competitors scrambling for answers. Buck Baker added 3 more victories to Chevrolet's tally, while the brand collectively snatched 38 NASCAR wins in 1955, a complete demolition of Ford's racing reputation. But those same engines that conquered racetracks were self-destructing in customer driveways with alarming regularity. The racing preparation that kept track engines alive, constant oil changes, precise tuning, and expert maintenance, wasn't happening in the real world. Street engines suffered the consequences of the 265's rushed development in ways that racing engines pampered by professional crews never experienced. Thomas himself captured the tragic irony perfectly. This little mouse has the heart of a lion when it stays together. You got to nurse it, but boy does it run. Buck Baker was more blunt about the street reality. It made power Ford couldn't touch, but you listened for the death rattle every lap. The racing glory was masking a streetcar catastrophe that threatened to destroy everything Chevrolet had worked to achieve. Chevrolet's response to the 265's reliability crisis was swift and decisive, proving that even engineering disasters could become learning opportunities. By the 1956 model year, GM had implemented the fixes that would transform the oil-starved assassin into the foundation of the most successful engine family in automotive history. The most critical improvement was the introduction of full-flow oil filtration as standard equipment. Instead of the pathetic bypass filter that cleaned only 10% of the oil, every drop now passed through proper filtration before reaching critical engine components. This single change eliminated the metal particle contamination that had been destroying bearings and wearing cylinder walls like liquid sandpaper. Piston clearances were opened up to provide thermal expansion room that the original tight tolerances couldn't accommodate. The engineering team learned that their precision manufacturing had been too precise for real-world thermal conditions. Southern climate failures disappeared almost overnight when pistons were given adequate clearance for heat expansion. Positive crankcase ventilation systems were finally implemented, solving the oil blowby and pressure issues that had plagued early versions. Improved breather designs and better camshaft lubrication addressed the rush-to-market shortcomings that had marked the 265 as essentially a beta test engine. The irony was profound and lasting. The very flaws that nearly killed the 265th became the foundation for small block reliability that would span decades. Every lesson learned from 1955's failures was built into subsequent generations, creating an engine family that would power everything from Corvettes to pickup trucks for over 50 years. The beautiful disaster had become the blueprint for automotive immortality. The 265 Turbo Fire stands as automotive history's most successful failure, a masterpiece of engineering brilliance sabotaged by corporate desperation and impossible deadlines. But the haunting questions remain. What if Ed Cole had been given just one more year to perfect his revolution? What if Chevrolet had resisted the panic and properly developed the oil filtration system from day one? Would the 265 have emerged as the reliable legend it deserved to be, rather than the beautiful disaster it became? Could proper thermal testing have prevented the piston seizure epidemic that plagued southern climates and racing applications? What if Ford's Y-block hadn't forced Chevrolet's hand with such brutal urgency? Would Cole's team have taken the time to implement positive crankcase ventilation, adequate breather systems, and proper camshaft lubrication from the start? The rush to market created problems that took years to solve and nearly destroyed Chevrolet's reputation in the process. The cruel irony haunts automotive history. If those early failures had killed customer confidence completely, would the small block dynasty have ever recovered? Could Ford have dominated the muscle car era unchallenged, leaving Chevrolet to play catch-up for decades? Perhaps most tragically, the 265's flaws were entirely preventable with proper development time. Every failure mode was solved within 2 years, proving that the engineering was sound, but the execution was fatally rushed. The 265th succeeded despite itself, becoming the foundation for automotive legend built on lessons learned through customer heartbreak. The engine that saved Chevrolet by almost destroying itself first. Sometimes legends are born from beautiful disasters, and sometimes the greatest victories come from learning how to fail better. Hit subscribe for more stories of automotive triumph built on tragedy.